back to another video, another project. So I have been always fascinated by the Apple ecosystem, especially how like the iPhone, Mac shortcuts and local automation can work together. So I wanted to build something that is not just another dashboard project. This is SentinelOS. It's a self-hosted personal intelligence and monitoring platform running on my Mac, controlled from my iPhone and powered by Docker, Kafka, FastAPI, Redis, MongoDB, Cassandra, Neo4j, Airflows, PySpark, Prometheus, Grafana, and Flutter. So as you can see here, this is my phone. So I'm going to enter to the application, and it shows me a dashboard panel in here, as you can see. So sorry. So I can see like the system load, and it's refreshed every 15 seconds. I can see the system health KPIs, the Docker platform, containers, how many stopped, how many containers running, and it's refreshed. And there is the personal intelligence, like for my portfolio, is it up or down? Habits, is it like the rate of accomplishments, the AI cost, APIs, and alerts. Here contains the Docker containers that I'm running. So within here I have the alerts, like the habits alert for workout is missed, weather alert for the FS whether it's hot, and etc. And then for the reports, those are Spark, like Hive queries that query the analytical data warehouse and the database, and shows the results within here. And we have here the about, it's like just explaining the architecture and tech stack used. And the most important part, it's here, the control center, where we use the shortcuts to like start the whole platform within the Mac. So just one click on the button and the platform is going to be launched within the Mac. I can stop, I can restart, I can run the analytical job that is based in like it's monitored, and it's like orchestrated by Airflow. So for example, if I clicked on stop the platform, I'm going to be redirected to the shortcuts application. So by running like stops as you can see in here, if I open Docker, you can so the containers are stopped. So that's the effect of clicking on these shortcuts, and the same thing goes for the other shortcuts. And so the idea is simple. My Mac runs the platform, my iPhone becomes the command center. So in order to build this, here is the architecture that implements everything. As you can see, the architecture is event-driven. Collector monitors, like the system monitor resources, Docker container, external signals, and AI cost simulation, and personal habits. They publish events to Kafka, then processors consume those events and store them into different databases depending like on the access pattern. Redis is used like for the latest state and fast dashboard reads. MongoDB stores raw documents, events. Cassandra stores time series metrics. Neo4j stores alerts relationships as a graph. Airflow orchestrates analytics jobs. PySpark generates KPI reports. FastAPI exposes the backend. Flutter consumes mobile-friendly endpoints, and Prometheus and Grafana monitor the platform itself. So in order to like dig into the details of the project, let's get started. So welcome back, guys. Now let's get into every section step by step, and let's start by showing the Docker Compose. So here is our Docker Compose file that contains all the services, volumes, and stuff. And now, as the platform is running, let's take a look at the containers that we have. So we have for like the Kafka, for Airflow scheduler, MongoDB, Redis, Neo4j, Airflow, Prometheus, and I mean we can see them also in here. So as you can see, here is our application. So we have for the events processor, collectors and processors, FastAPI, Grafana, Airflow has for like the Zookeeper and Postgres, and also the web service. So yeah, and let me show you as well here. So let me just drag this one and clear here, and let's look at the so I better just copy this in here. So here are the topics, Kafka topics we have. Then we have the habits log, system metrics, external signals, and Docker events and alert events. So Kafka is the backbone event. So each domain has its own topic. As displayed in here, those are all the topics that we have. And now let's go to MongoDB and show. So I'm gonna run the container of MongoDB. It's ls, I think it's Mongo, and it's Mongosh. So now I'm inside the container. So let's use our database. So now I'm here. Let me show all the collections we have. So we have the raw Docker events, raw external signal, and raw system metrics. And now I can show, for example, here for the raw system matrix. I can just display here limits of just 2. Okay, so now here are the documents we have, the 2 documents, and same for the other raw events. So MongoDB stores raw events documents. This is useful because the structure of external signals, system metrics, and Docker events can evolve over time. So that's why. Then we have, so now I'm going to exit. Okay. So welcome back, guys. Now let's get into every section step by step, and let's start by showing the Docker Compose. So here is our Docker Compose file that contains all the services, volumes, and stuff. And now, as the platform is running, let's take a look at the containers that we have. So we have for the Kafka, for Airflow scheduler, MongoDB, Redis, Neo4j, Airflow, Prometheus, and I mean we can see them also in here. So as you can see, here is our application. So we have for the events processor, collectors and processors, FastAPI, Grafana, Airflow has for the Zoom. Then we have Redis. So for Redis, the idea is it's Redis is used for real-time state. So the mobile dashboard doesn't have to read and scan historical databases every time. So it reads the latest system and Docker status from the Redis through FastAPI. Then we have for Cassandra, so say SSH. So now we can use the SentinelOS table. Okay, forgot. We can run select from Docker container events. Just let's limit on 5 rows. That's enough. So as you can see here, we have the limit of 5 on the table Docker container events with a timestamp. So Cassandra stores time series metrics. It's a good fit for high volume append only operations and also operational data like CPU, memory, disk, container metrics, and external signal history, and that's why we used it. We have all. Now let's show the Neo4j graph, and we can do that by going to here. Okay, I think that's what this. Okay, so now I believe I have stored this query, and if we run it, we'll get the result. So Neo4j is used for graph intelligence. So here we have the like here the application. It's related to 18 alerts. So here this is an external alert, and it shows many like the relationship between the nodes. Here is the signal. So here it says the system monitoring, and the CPU usage belongs to the system monitoring. And we can also like run, for example, another query in here. Like let me run, for example, this query, and here shows us only the alerts. We have 20 alerts. So those are external alerts. This is external intelligence, and so instead of treating alerts as isolated records, I model like relationships between the mobile app alerts categories and alert events. So this allows me to answer questions like which alerts belong to which category and which application received them, and how different monitored domains are connected. So this is really helpful. And we have the Airflow orchestration master. We have two DAGs in here. We have one for collectors DAG, so this one makes us able to run the collectors, and this one for the analytical job. So for example, if I run this one, I think it just have to reconnect to Airflow. So here, yeah, admin and password. Yeah, so here if I run this one, and I can see that it's running, the status is running, and when it's succeeded, it's going to give us the succession status. So now here is the log of it, here is the Gantt diagram, and now success. So that means the DAG is successfully and just like made the analytics that we have using PySpark. So here Airflow is used as an orchestration layer. It schedules the collectors and analytics jobs. This DAG, as I said, runs the PySpark KPI job that generates the analytical reports. So in order to like see those reports, we can find, I think, I'm still here in the Cassandra container, so I can do this, and I can go to warehouse, and I have to go as well to system KPIs, and just click on type, so to see the type of files we have. So we have like Parquet files, that means it's successfully generated the analytical reports, and the code responsible for this is, I can go in here to services, analytics, and daily KPI job. So this is the file responsible for the analytics, and the data is within here. It's stored as Parquet files. That's it. So the Spark job reads the raw events, calculates the system level KPIs, and writes Parquet's reports into a local warehouse. So this is the analytical layer of the project. Then let me show you the FastAPI parts, which is here. So first of all, we have to connect. So by entering the data and getting the token, and then by going to authorize and paste the token we have in order to test the endpoints we have. So this endpoint give us the health. We have the matrix Prometheus endpoint. We have many endpoints. We have the mobile overview endpoint. So first of all, FastAPI exposes a secure JWT APIs for mobile app. I created clean mobile specific endpoints, so Flutter does not need to understand Redis, MongoDB, Cassandra, or Neo4j, and it's done by those three endpoints: mobile overview, mobile alerts, and mobile reports. So this reports mobile endpoints powers the Spark report screen. This one of alerts powers the alert screen, and this one, the overview, powers the home screen. and that's it. Now if we go to Prometheus, if we go to the status and go to target health, we have here app. So this is our endpoint. So Prometheus monitors the platform itself. It scraps FastAPI metrics such as API requests and endpoint activity. And here is the the query is SentinelAPI request total. So if we went here and we run the query, this one, because this one that we have implemented, it gives us the requests. We have 2 and 3 in here. And now Grafana helps us visualize the it's the engineering observability layer. It shows API traffic, it shows total requests and active endpoints. So if I click on refresh, here we have 5 total requests, active endpoints, and the traffic API rate. Now that we have seen all the parts of the application, let's go to the Flutter application. So first of all, I will have to run the simulator. So let me check. So then I will run Flutter clean. First I have to go here actually. Clear and Flutter clean, and we have okay, Flutter okay, and we have first of all let's clear this and this. So here is the application. So the home screen gives here the login page. So now the home screen, which gives the dashboard, it's a quick operational overview, system pressure, CPU memory, disk, stats and portfolio uptime, AI cost simulation, and habit completion. So as you can see in here, then we have the Docker screen shows all the platform containers and then their runtime state. We have the control. So this is one of my favorite parts, as I already specified within the first beginning of the video. The app launches the iPhone shortcuts. Here within this simulator, I don't have the shortcuts already created. That's why. So we're going to head back to the application. We have the alerts. So are backed by Neo4j graph relationship. We have the reports are generated by PySpark and exposed through FastAPI. We have the about screen. This is just summarizes the stack and architecture directly inside the application. And yeah, so this is what we have implemented so far. So SentinelOS started as an idea of to combine my interest in the Apple ecosystem with data engineering and platform engineering. In the end, it became a full local intelligence platform with streaming, orchestration, multi-database storage, graph relationship, observability, analytics, backend APIs, and mobile application. It's not just a dashboard, it's a small self-hosted operating layer for my digital environment. The next improvements would be maybe Firebase, push notifications, real sports and market APIs, for example, strong authentication, and more advanced anomaly detection, why not? And yeah, thank you for your attention, and see you in another next video. Goodbye.